If you're building anything for the web today, and I mean anything, from a simple app to a massive distributed system, you're relying on one single fundamental concept to make it all work. That concept is the REST API, and honestly, mastering it is pretty much non-negotiable.
Just think about it for a second. Your phone is talking to Twitter's servers. Your smart fridge might be pinging Amazon. Your web browser is constantly chatting with Google. How does this massive, kind of chaotic orchestra of technology not just completely fall apart?
Well, the answer is actually surprisingly simple. They all agree on a set of rules, right? A common language for communication. And that language is called REST. It's basically the invisible backbone of the entire modern internet. So in this first part, we're going to break down exactly what REST is, and probably more importantly, why understanding it is an absolute must for anyone working in software.
Okay, so the first and by far the most common mistake people make is thinking REST is some kind of strict protocol, like TCP/IP. It's not. It's so much better to think of it as a philosophy, an architectural style. It's really just a brilliant set of guidelines for designing apps that are simple, super scalable, and don't break easily. So what are these guidelines built on? Well, it boils down to 4 core ingredients. First, you have resources, which are just the nouns of your system: a user, a product, an order. Second, you've got URIs, which are like the unique street addresses for those resources. Third, you have HTTP methods, which are the verbs you use to interact with them, like get or post. And finally, you get back a representation of that resource's state, which, let's be honest, is almost always in JSON format these days. And why do we even bother following this style? Well, the payoff is huge. Because REST is built right on top of HTTP, something everything already understands, it's incredibly simple. And that simplicity leads to amazing scalability, so your systems can grow without collapsing. And you get interoperability, which just means pretty much any device in any language can join the party. It's a design that just plain works.
Okay, so if REST is a style, what makes an API truly RESTful? That's where the constraints come in. You can think of them as the 6 core commandments you have to follow to get it right. So here they are, the 6 big ones. But for now, let's just focus on the 2 that are, without a doubt, the most important for building massive, scalable systems: statelessness and the uniform interface. First up, statelessness. The core idea here is simple. The server has amnesia. It doesn't remember a single thing about you from one request to the next. That means every single request you send has to be a complete package, containing all the information the server needs to do its job, like your authentication token, for instance. And why is the server amnesia such a superpower? Because it means any server can handle your request. You don't have to worry about sticky sessions or making sure you keep talking to the same machine. This makes scaling out, just adding more servers, incredibly simple, and it boosts reliability like you wouldn't believe.
The second giant is the uniform interface. This is truly the soul of REST. It basically forces us to use standard ways to identify things, manipulate them with formats like JSON, and make our messages self-descriptive. It also includes this idea called HATEOAS, which is a fancy way of saying the API itself gives you links to guide you on what you can do next. This uniform contract is what separates the client from the server, letting them both evolve independently without breaking each other. It's brilliant.
All right, that's enough theory for now. Let's get practical. How do you actually design a clean, intuitive, and professional REST API? These are the best practices that senior engineers and, yes, interviewers absolutely expect you to know.
First and foremost, please, your URLs should be about nouns, not verbs. The resource is /users. The action you want to take is communicated by the HTTP method, like get or post. Putting verbs in the URL like /det_users, that's a classic rookie mistake, and it just screams that you don't get the core idea. As you can see, you've got this standard set of HTTP verbs to play with. Get to retrieve, post to create, delete to remove. Simple enough. Now for updates, there's a really key distinction here. Put replaces the entire resource. Think of it as replacing a whole user profile. Patch, on the other hand, is for partial updates, like if you just want to change a user's email address. Sticking to these standard meanings makes your API predictable and a joy for other developers to use. Think about the most frustrating bug you've ever had to track down. I bet it started with a completely useless error message. Don't build that API. Instead of just saying something went wrong, be a lifeline.
A good error response is a nice JSON object that tells the developer exactly what the problem is, which field is causing it, and maybe even how to fix it. It turns hours of frustration into a quick 5-minute fix. And finally, please plan for the future. Your API will change. It's inevitable. To avoid breaking all the apps that already rely on it, you should always version your API right there in the URL. A simple /v1/prefix is the industry standard. It's clean, it's clear, and it makes your API stable for the long haul. So now you've got the theory and the best practices under your belt. Let's put it all together and see how this knowledge helps you totally nail those high-stakes system design and backend engineering interviews. Okay, here it is. A classic interview question you are almost guaranteed to get. The interviewer leans in and asks, "So, how does using a RESTful architecture help you scale a system to millions of users?" Your answer, in one powerful word, is statelessness. Because each request is a self-contained unit, and the server holds no memory of you, you can put 100, 1,000 servers behind a load balancer, and any one of them can handle any incoming request. It is the absolute key to simple, massive, horizontal scaling.
And hey, if you really want to sound like a pro, it's important to use the right terms. REST is the architectural style itself. A REST API is an API that generally follows those principles. But a truly RESTful API is one that is fully compliant with all of those constraints we talked about. Knowing that little distinction really shows a deeper level of understanding.
But you know, a truly great engineer doesn't just know the rules, they know when to break them. REST is incredibly powerful, but it is not the silver bullet for every single problem out there.
For instance, if you're building a real-time chat app or a live dashboard, that classic request-response model of REST is just too slow. You'd want to use something like WebSockets. Or if you have a mobile app that needs to fetch really complex, nested data efficiently, GraphQL might be a much better choice so you can avoid making dozens of separate API calls.
Ultimately, it all comes down to this. The number one rule of system design is to choose the right tool for the job. You have to understand the trade-offs, know the alternatives, and make a smart decision based on what your system actually needs to do. So we've covered the what, the why, and the how of REST APIs. You've got the principles, the best practices, and you even know its limitations. The real challenge, and honestly the mark of a great engineer, isn't just memorizing the rules. It's knowing when to apply them, and when choosing a different path will lead to a truly exceptional system.